Good morning, good afternoon, good evening, everyone. For those who are attending or potentially listening to the broadcast later on, my name is Klaus Frost, and as mentioned, we're going to talk about MV2 and the way in which it provides shop floor capabilities for those running business centrals. So as mentioned, my colleagues, Erin Bondi, she's marketing executive here and co-owner at ISE. I'm on the sales side and customer service / success. And then Rick Reith, our senior manufacturing engineer. And between all of us, we've got decades of experience within the world of ERP, Business Central, as well as manufacturing. So we're delighted to have everybody attend the event today. So with that, I'm going to transition over to Rick, and he's going to talk about the actionable data and presentation of the solution. Rick?
Yeah, thanks, Klaus. I appreciate that. You think about today's world, right? Today's world is really driven off of data, and manufacturers have always been in that mindset of saying, I want to continuously improve, my throughput, my cost of goods. I want to minimize things. It's a very competitive arena that we live in with these manufacturing companies. And then taking that big data that we're kind of all used to these days, that we all live and breathe in on our cell phone, our smart devices at home, et cetera. We're using that data to make changes. The key word here is actionable. We want to give, our users, both on the shop floor all the way up through the C-level group, those information data points that they can make action or they can perform actions on. It's that data that is driving an action. So it's really empowering those people to actually do different things. I'm going to kind of walk you through just maybe a couple examples and then go into some live demo code as well. You think about actionable data, right? On the shop floor, or inside your manufacturing facility, you've got really three pillars of data. You've got your material, you got machine, and you got your manpower. All three of those things combine to actually tell you whether or not you're going to kind of quote unquote win the day. If I have, material available, that's great. I can actually run, something. If I don't have a machine, now I can't run it. I need manpower as well to be interjected into this, little world to say that all three of these things need to be kind of alive and running and be as efficient as possible. So kind of going into this machine, a really good example from one of our customers who, they were posed with the problem saying that they had a machine that was at 100% capacity. And mind you, they run 3 shifts a day and they run 7 days a week. This machine was producing about 9 million pounds of aluminum per year. When I say producing, it was actually processing. So it was actually producing about 9 million pounds of parts. This company actually does aluminum extruding. And then from that extrusion, they'll actually, cut those parts into different things based on their customer needs. Well, they were given a capital request to say, we need another machine because we're at 100% capacity. Obviously, I can't add more people because it's already running 3 shifts a day and 7 days a week. And they went to the ownership group and said, well, we need another machine. The supervisor, the plant manager, and the operators all kind of told their story of why they needed this additional piece of equipment. So they kind of backed up one step and said, well, let's just analyze, this piece of equipment that we're looking to buy is actually something that we already have. It's just maybe not utilized. So they started analyzing the uptime of that machine and capturing the downtime and the reasons for that machine and why it was going down was a big part of that. And then they continued to analyze and adjust and repeat that process. So they made incremental gains, understanding that this machine was really not up 100% of the time. And that's almost impossible because obviously you have machine maintenance and just standard kind of downtime for setup and everything else. However, they were finding bits and pieces of time where that machine was waiting for parts or that machine was actually being jammed by some chips of the aluminum that were getting, bogged up into the fixture, not allowing it to cut it accurately. So they had to constantly open up the machine and actually clear out the chips and then start the machine up. Well, lo and behold, after they've done this, and this was over, a number of years, they took that machine from producing those 9 million pounds of aluminum per year to 16 million pounds per year. They've almost doubled the output of that machine. They didn't add a new machine. They didn't add any additional resources, which means they didn't add new employees or anything else. They really just analyzed the downtime of that machine and were able to actually put little Kaizen events out there on the shop floor to investigate why it was going down, what they needed to do, changing. And again, the changes were across the board. They had some material issues, from their suppliers. They fixed those. They had some fixture issues. So they had their tool and die department actually change the fixtures. They had some operator issues as well, as far as, being available at the time to actually load parts into that machine, et cetera. But over the course of, a couple of years, they actually doubled the output of that machine. And you just think of that from a perspective, what that does for that manufacturer, right? They, didn't incur the cost of that new machine, which is usually in the seven figures. They didn't have to worry about, where do I put this machine now out on my shop floor, and how do I put it in a place where it's actually within my value stream, so I'm not introducing extra steps and processes for moving material around. They didn't have to add any new additional people to double the output of that year. Here's kind of what we did for them, right? The machine that they were specifically looking at was a Haas machine, which is an automatic CNC machine that has multiple heads and can cut different pieces and cut different factors. We started capturing the data, and we started capturing it directly as well as through a third-party factory whiz kind of application. But it doesn't have to be. It could be other applications that have communication that maybe that machine already is tied into. Sometimes that machine, like this Haas machine, has the ability to connect through an Ethernet port or an RS-232 connection to actually send data. What we do is we capture and process that data through our machine integration layer, and then ultimately through our MES application, MV2, to actually, adjust production, adjust inventory, throw up some KPIs, and then also do some analytics. And most importantly, in my mind, is start alerting people. So every time that machine would go down, there would be an alert message, both visual, meaning that the operator saw that it was down. There's a little red flashing border on the screen. There's a dashboard up on a TV monitor on the wall that shows that machine going down. And then there were emails under the covers that were getting sent out to different departments, depending on who they selected. It was the maintenance department. Traditionally, it was the supervisor, and then maybe somebody else that says, this machine went down, you need to take care of that. And then ultimately, all this information is also ultimately sent back to ERP, so in Business Central in this case. Let me just take a quick view of that from a software perspective. So from a software perspective, you heard Klaus say we've got different user interfaces and experiences. From a dashboard, this is what they potentially could see. They could see a number of work centers that they subscribe to and say, all right, I want to see the status of these work centers. And I happen to choose 13 different work centers to display to you. You can immediately see I've got 2 work centers that are red, because those are my exceptions I want to deal with right now and take care of. And they are both down. One's for a mechanical reason, the other one's for reason D4. I can see on the other side of the spectrum, I have something here that's green, which means that this is running a job and it's running correctly. It's running on time and to rate. That's great. I have yellow ones, which means that those work centers are running jobs, which is great. And you can see the production order they're running and the item and the actual versus expected and all that stuff. But it's taking more time than what's expected. Another good indicator that I'll get into a little bit later, to say something is wrong out there in the floor, that I need to correct it. And then we've got idle work centers that are blue, and we've also got one that is, sorry, idles are orange. The blue one is actually doing setup. And you can even take this to say, well, maybe at a work center level, I'm going to go into those work centers that are down. This one has been down for an hour and counting. And as you can see here, there's that red border I just mentioned earlier. So the operator knows that on their device that they're looking at, which would be this screen. But then you also have supervisors that maybe look at it from this perspective, and I can see that one's down for that time. This one's down for 23 minutes. There's also additional dashboards that can be created, and you guys create these on your own. You don't need to be a developer to do it. I have one out here called RIC2, and if I look at this one, I can see here on the left-hand side of my screen, I can see these are my 2 machines that are down. One's been down for just a little over an hour. The other one's been down for 23 minutes. And they get color-coded based on some thresholds that you can define. And then up above here is something where I can see that I'm running a job for 23 minutes. I should have expected to already reported 7 pieces, and 0 pieces were reported. Again, a good indicator out there to a supervisor and the operator and everybody within that business that things are running slower than what's expected. I can address it right now and take care of it, rather than waiting until the end of the day, the end of the week, the end of the quarter, whatever it may be. So Another good indicator for this downtime was they could actually drill into it. So I could say, take my metrics and go into downtime here. And I'm looking at the downtime. I can say, well, what's the last 2 days? Or maybe I want to take this over the last couple of years and change it to maybe a bar chart because it looks a little prettier. And now I'm actually, showing a metric here of all the downtime that has been accumulated across the work centers that I chose, which is all of them. And it's going to sort them in worst performing on the left-hand side to best performing on the right-hand side. And then down below are all the individual events that caused that machine to go down. And if I wanted to, I could actually drill into like line number 1 here, and I can see line number 1 says, all right, electrical is the main reason this machine is going down. Next, followed by material, then by a sterilization activity, and then by a mechanical reason. So these are the pieces of information that customer used to kind of drive into why was that machine going down, and then make the necessary corrections to eliminate the material problems or the electrical problems or the manpower problems, which gave them that huge benefit of avoiding a very costly event of getting a new asset in place and hiring individuals, et cetera. My second example I kind of want to walk through is just kind of from a data accuracy standpoint. Another customer of ours, they actually make tiles. When I say tiles, you think about going to your big box stores for Home Depot. You've got your patio pavers, but those are some of the tiles they make. But they also make big staircases for large universities as well as companies. They make, the Target red balls you'll see. They also make like outdoor patio furniture at like a Culver's or McDonald's. So they had a heavy paper process, and they saw a lot of delay in information and errors. And they saw some different rates for products as well as work centers. And what the paperless system did allowed them to see is that, as you saw me earlier, machines were running slower than expected. Well, why was it running slower? As you looked into it, they found out that it was using a rate for this 2x2 tile for all 2x2 tiles, and some were different than others. Some had a little bit more density, some had a little bit more aggregate that went into them. So what they were able to uncover is that they adjusted their rates differently based on the item that was being manufactured, as well as the work center that it went through. And then they were able to actually adjust their cost and price of those products. So bottom line, it immediately adjusted the price because it took more effort to make certain types of those 2x2 pavers because of the aggregate or the machine it was running through. A huge cost saving, and actually I was going to say productivity, but it's actually profit. They increased their profit margin as well. The same company had the same issues kind of with paper out on the inventory side of their business, where they had delayed information as well. They have 5 buildings with 2,400 locations. Really finding information was a big nightmare for them. And their accuracy was about 75%. So if you think about just the accuracy and then people running around the shop floor or the warehouse trying to find material that they think it's supposed to be in one location, but it's really not. Or maybe it's there, but they don't have enough in that location to satisfy what they're trying to do. So they got to go to multiple locations. Well, they went through a process of saying, all right, let's actually improve this inventory. They turned on something which is called backflushing, which I know you guys know about maybe, or maybe you don't, which is consuming the inventory at the actual time that material was actually being used. They put tablets and handhelds out there for the material handlers, having them do the transactions, or when they moved material, when they took it out to the line, when they received it in at the dock. They took their inventory accuracy from that 75% all the way up to 99%. What this did for them from a business standpoint, it eliminated the need to do a physical inventory across those 5 different warehouses and buildings. And then also they ultimately reduced the cycle counts and their auditing requirements from an outside source. And what they now do from an auditing perspective is their auditors said, all right, if you can maintain this accuracy, I think they gave them a level of 98% accuracy. If you can maintain 90%, 8% or above, we only have to go and audit or do a cycle count of maybe 15 items rather than 100 items. So they would come in, basically give them a sheet of 100 items. The auditors would choose about 15 of those items, go and do the counts. If they were accurate above 98%, they would say, all right, you're done. The audit is complete. It saves them a gazillion amount of time as well as dollars. From a application standpoint, this is kind of how that works, where if I'm looking at, my shop floor here, I can, I'm just pick a different work center. I'm going to take this one based on the jobs that are supposed to be running in this work center. I can actually go and look at information like on the shop packet to see my bill of material, what's going to be consumed at this step of the manufacturing process, what's not going to be consumed. I have all the material out here to say, here's all my locations and the quantity in hand. I can dive into these to see additional information if I want to say what specific location has what quantity. If you're using FIFO, if you're using batch lot, if you're using serial numbers, those all play a part in that inventory management. And from an operator's perspective, they're literally just starting and stopping jobs, reporting the end items that are complete. The consumptions are handled automatically. From a material handler standpoint, they can come out and do a issue material transaction where they could say, I'm just going to issue material, and it's asking me for a badge number. And now I can say, well, what do I want to issue? And I could say, I want to pick and choose the different items. I could put a quantity across the board and pick them all for everybody. They could also do this on a handheld type of device. So these devices are, built and designed for either small real estate handheld type of devices, where if I want to do a transfer material, I'm going to basically scan in information from a label. I can also type it in here if I want to, or you see there's a search button here as well, where they could actually search for the items that they're looking for and then do the warehouse transfers from there. But all of this stuff is kind of eliminating that paper, making things real time, but most importantly, making it accurate, and then giving the triggers to the supervisors, to the workers, to the C-level, everybody within the company to say, all right, there's an issue that needs to be addressed, whether I'm running low on material, whether a job is running slower than what's expected. Those are all the types of information that people want to know in manufacturing so they can improve their productivities, efficiency, and ultimately their profit. With that, Klaus, I'm going to kind of turn it back over to yourself.
All right. Thanks for that, Rick. I think some fantastic examples of, there we go, of the way in which MV2 could be considered as a shop floor command center, being able to look at all the different components, aspects of manufacturing, inventory, even your example with the aluminum extruder of the different types of visibility that we provide, either in that particular case, coming from the machines, the downtime, and doing your Kaizen events and going from 9 million pounds to 16 million pounds, just a fantastic example of that. And then the second one with the tile manufacturer and being able to eliminate physical inventory. I'm sure there's a lot of people out there in the manufacturing space that would love to be able to do that. So that's very much about the tools and how we can do that for our customers. Thanks, Chad.
Thank you very much.
Thanks, everyone.
Thank you.
Bye-bye.